new work I'm really excited about and looking to get feedback on, so all questions will be great. So it's really worth looking at the causal effect of education on cognition in low and middle income countries. We know that education is seen as an intervention to reduce dementia, and one of its mechanisms is cognition. Performance on cognition tests usually used as one way to diagnose whether individuals have dementia or not. And even if education doesn't affect cognitive decline, by raising the baseline levels of cognition, it delays the age at onset, which could have huge ramifications for population burdens. But the question still remains is whether this effect is causal or not. And I'm really surprised about how little work there is done on this causal relationship between education and cognition at older ages. Is it education per se, or a confounding factor like genetics or family environment, and especially for low and middle income countries? So this forest plot over here displays most of the results. So we have one study for China, which used the Charles dataset using the Chinese Great Famine as a natural experiment. And they found additional one extra grade year of education increased immediate and delayed memory scores by about 0.10 of a standard deviation. A working paper using Halsey for South Africa using instrumental variables with schooling costs finds larger effects for delayed memory than immediate memory. And then all the other evidences for HICs, all coming from natural experiments using education reforms, apart from one paper, Hurd and Sisensky, using a sibling design in the Wisconsin longitudinal study. And the effects seem to be larger for the US. So in the US, an extra year of education increases memory scores by about a third of a standard deviation. In the UK, this paper used a reform where education was increased from 14 to 15, found an effect of about 0.5 of a standard deviation. Another reform going from 16 to 17 when you could, 15 to 16 when you could leave school, found effects about 0.4 of a standard deviation. And then much smaller effects coming from European countries in the shared data set around about 0.10 of a standard deviation. Now, my take is that the lack of evidence for LMICs is partly due to the difficulty in finding natural experiments that can be applied to these data sets. So we've taken a different approach. We're not trying to identify the true effect, but say what is a possible range of this causal effect. So we use the same econometric method from the WHO SAGE surveys where we have harmonized data. And this table really summarizes our key findings, where most of the action we see is at the level of where we compare individuals with no education to those who completed primary school. So we find that comparing these two groups, an extra year of education could increase memory scores by about 0.02 to 0.12 standard deviations in China. And I've put a column for the proportion with no schoolings, because one of the interesting aspects is that we have some countries with similar schooling distribution. So India and Ghana, where almost over 50% have no schooling. But the estimated upper bounds differ. Same thing for South Africa and China, much lower proportion with no schooling, but a big difference in the estimated upper bound. So talking about the method we employ, if we want to know, say, for example, what's the effect of going from no schooling to primary schooling, this expression here, my expected cognition with primary education minus my expected cognition with no schooling, and we want to write out the expected outcome. The problem is these missing counterfactuals. We know all these terms. We know how many people have less than primary schooling, what the expected cognition score is of people that get primary schooling, but we don't know what would have, for people with no schooling or less than primary schooling, what their outcome would have been if they got primary schooling, and for people with more than primary schooling, what their outcome would have been if they got primary schooling. So we make assumptions to fill in these numbers over here, to summarize in this diagram. Our first approach is just to say these counterfactuals are replaced by the minimum of the outcome and the maximum of the outcome. Then we have this, what's called the monotone treatment selection assumption, which assumes that on average, more educated individuals have higher cognition scores. So we say that for people with less than primary schooling, their cognition score cannot be more than that of cognition score people with primary schooling. And for people with more than primary schooling, it has to be at least the cognition of people with primary schooling. So these tighten bounds. Then we have an assumption called monotone treatment response, which basically says that more education doesn't lower your cognition and tightens bounds by replacing these minimum values with the corresponding sample expectations. And then these two assumptions can be combined to give us fairly tight bounds as well in these expectations. So under each of these different assumptions, they can be combined with what's called a monotone instrumental variable, a variable that has a monotonic increasing or decreasing relationship with outcome. So our outcome is cognition, and we use height. So we're basically saying that expected cognition for people that are really tall is greater than expected cognition outcomes of people, say, medium height and lower height. The way this works is that you take your MIV, this height variable, and divide it into bins or subsamples and compute these bounds under each of these assumptions. So here's a fictitious diagram where I have height divided up into 3 bins, and these black dots would represent the upper and lower bounds computed. And then to tighten the bounds, for the lower bound, I take the largest value over all bins where z is less than or equal to n. So in this case, for bin 2, this lower bound gets replaced by the largest value, which comes from the lower bound in bin 1. For the upper bound, I take the smallest value. So for bin 2 over here, this upper bound gets replaced with the upper bound from bin 3. And then we take the weighted average. So going back to the expectations, we're just plugging in, going to our data set, finding mean values of cognition scores, the proportions of people with different levels of schooling, and putting these into these expected value equations. And then you calculate this change, what would be the improvement of going from having no schooling to primary school by doing these subtractions of the upper and lower bounds. And we have a working Stata command, if anyone's interested, that computes all this in Stata, so you don't have to do it manually. Data is the WHO SAGE surveys, where they for wave 1, where they oversampled older individuals. Outcome is going to be the CIRAD, immediate, delayed, and word list recall task, where they had a word list of 10 words, and they were given 3 attempts and asked to repeat the words after an immediate short delay, and then after a bit of a longer delay as well. So some quick summary statistics. Average age is lowest in India. They also have fairly low average years of education, with over 50% with no schooling, similar to Ghana. China has the highest educational attainment, but that doesn't necessarily translate into the best performance, or at least the average score on this word list recall test, where it's 21.79 in China, but it's higher in Ghana, even though a bit more people have no schooling in Ghana. So going back to some of our main, so here are results for China. So what this tells us, this is the no assumption bands, where we just use the minimum and maximum of the outcome to replace the missing counterfactual, saying that going from no schooling to primary schooling could reduce your test memory scores by 30 points or increase it by 32. Then we apply different assumptions. I just want to make a note on this MTR assumption here, that the lower bound is usually mechanically 0, because we're assuming that schooling cannot lead to lower memory scores. So even if you compute it manually as negative, our assumption says that schooling cannot deteriorate cognition, so it's replaced with 0. Could be more than 0. And we get fairly tight bounds when we combine them. These are our main bounds, saying that the effect could be anywhere between a 0.65 increase and a 4.92 point increase. So putting this in terms of relative to the standard deviation of people with no schooling, represents a 0.10 to 0.73 standard deviation range. And then if we assume there's a difference of 6 years of education between individuals with no schooling and primary schooling, that says an extra year of education increases memory scores between 0.1 and 0.12 standard deviations in China. How does it look for all countries? So if we compare no school intervals with primary, the estimated upper bounds are large in China and India, very large in Mexico, but smaller in Ghana and South Africa. In panel B, we have the comparison between people with less than some primary schooling and those that actually completed it. And you see that the estimated upper bounds are much smaller compared to this margin over here. And also, we cannot rule out no effects with confidence intervals all containing 0. Some other margins, so high school and secondary, I should just clarify that secondary school, it's not clear from the documentation data, but I think this really refers to junior high and middle school in this low and middle income countries. But again, we cannot rule out 0 effects. If we look at the comparison between primary school and high school, here we can rule out 0 effects, but this is a big margin as well. And then university and high school, I just want to bear in mind India, something I'll talk about at the end. The highest upper bound is actually for India, again, although the confidence intervals contain 0. A few charts to look at gender differences. So one of the problem here is that we're using bounds, so they tend to overlap, so you can't really see much statistically significant differences. But I think there's some suggestive evidence, at least for Ghana and India, that there may be some gender differences. If you look at estimated upper bounds for women in Ghana, it's higher than men, and same thing for women in India, it's higher for men. But going back and trying to recap, so this table shows the summary of our main results. And I found it interesting. We have these countries with similar schooling distributions, but different effects. And what could be the possible explanation? So kind of the ideas I've been playing around with is one, really school quality. So the cohorts born are 1900 to 1957 or so. So in Ghana and South Africa, these are periods of colonial times when school quality was low, and there's big discrepancy in what Black South Africans were being taught and what white South Africans were being taught. And especially with school quality being so important to cognitive reserve. So if the school quality was meant just because you got primary education in Ghana, could have meant, well, you weren't really benefiting from increases in cognitive reserve. Looking at India and China. So, I mean, just reading after India and China both went through changes in the late 1940s and 1950s. And India's had these education plans where after independence, we really concentrated on university, where the Indian institutions of technology were established university education and didn't really focus on primary, whereas China really focused on primary education, and its literacy rate increased much faster than India. And another thing is India still has a problem with teacher absenteeism today. So a lot of qualitative studies pointing to evidence that teachers would be absent from school because they live further distances. So is that quality there? Is there a lot of action with cognitive reserve? Another thing could be thinking about the channels. So there's the cognitive reserve story, but there's also access to occupations and doing jobs which are cognitive demanding. So again, thinking about the cohorts and periods of development, you may be getting primary schooling or university schooling, but if you're still working manual jobs or in agriculture, that may not be as cognitively stimulating. Maybe the benefits are there. But one other thing is, we're looking at the upper bounds for India and China. They're pretty similar, even though I've argued that school quality might be worse in India. So another channel could be midlife health and income. So this table over here just looks at the data and shows average scores for self-reported health on a scale of 1 to 5, and the portion of people reporting that they ever smoked for education level across countries. And you see some, interestingly, India and China, there's higher smoking rates in India than there is in China, a bit worse health in India and China as well. So maybe one possibility is that India has lower school quality than China for these cohorts in the data, but if they had worse health and schooling actually led to improvements in health, that could have also affected cognition as well. In summary, we think so there's large possible effects of primary schooling on cognition across these countries that differ. This is really different from the finding in high-income countries where the real action is completing high school. You're forced to stay in school another year, or you leave an extra year later, and this is where the benefits really show. And I guess what's really missing from the literature, what needs to be done, is unpack the mechanisms and look more into gender differences. And thank you.
So now